This lesson introduces you to radians. Radians are a new way of measuring angles. So far, we've always measured angles in degrees, and that works quite well for right triangles and right triangle trigonometry. For most higher mathematics, if angles are going to be measured, you're going to use radians. So what you see already on the screen is an angle in red. And what we're going to do to think of it as a radian measure instead of a degree measure is to place it on a coordinate plane. Notice that the angle is in standard position, which means the initial side of the angle is along the positive x-axis. And here's how we measure radians. Let's consider that this circle has a radius, let's call it r, and let's think about the angle that subtends an arc length equal to the radius. To subtend means that that's the arc that that angle slices out of the circle. So if you have an angle where the arc length right here in green is equal to the radius, which is in red, then what we say is that that angle measures 1 radian. And that is actually the definition of a radian. This works for any angle measure. So suppose you have the angle shown here in red. Again, it's placed in standard position. The circle has some radius r, and that large angle subtends the arc that I've labeled in green. And if you wanted to know how many radians that angle was, you would do the following. To get a radian measure for alpha, you would take the arc length s and divide it out by the radius r. It should make sense that you need to divide out by the radius because a circle with a larger radius, the same angle would correspond to a larger arc. In other words, let me show you what I mean by that. If we had an even larger circle, and I'm not so great at freehanding circles, but imagine you had a larger circle, then that same angle measure would subtend a correspondingly larger arc length, or s. So by dividing out by the radius, what that does is that makes sure that no matter what the radius is, you get the same radian measure for that angle. For convenience, we're usually going to work with the unit circle, and this is where it's going to get into what you actually have to start knowing really well. First, let's consider unit circle means that the radius is 1. So let's consider what the circumference of this circle is. Well, the circumference of a circle is 2 pi r, and in this case, since r is 1, 2 pi times 1 is just 2 pi. And that means if you want to know how many radians it is all the way around the circle, well, that angle would be your arc length, 2 pi, because that's the circumference, over the radius, which in this case is 1, so 2 pi. So what that tells us is that if we're using radian measures all the way around the circle, what we're used to calling 360 degrees can also be called 2 pi. Logic tells us that halfway around the circle, 180 degrees, should be half of 2 pi, or pi radians. And then if you think about it, up here at 90 degrees, well, that's halfway to pi, so we represent 1/2 pi with pi over 2. And then if you think about down here, you're from pi to 2 pi, halfway in between those should be 3 pi over 2, or 270 degrees. And this 360 degrees could also be called 0 degrees or 0 radians. For your homework, I want you to copy this unit circle that you see. Unit circle means the radius is 1. And I've labeled several places in blue along with the degree measures. What I want you to do is find the corresponding radian measures, and they're basically going to be in terms of pi. If you need help getting started, you can rewind to the previous screen where I've given you 4 of the locations already with degrees and radians. And the key again is to note that all the way around is 2 pi, so you're going to be taking fractions of that. We'll definitely go over this in class next time. It's really important that you become familiar with radian measures.